Hi, I'm Zakwan Ashfaq and my teammate is Deep Chaudhary. In this video, we're going to talk about our project StarCraft and what we did basically. So from over here, um, Deep did the resource gathering basics, build order production, and the attack timing. I did the scouting, the defense, and the natural expansion. And have we did try to implement our specialty, which is partially implemented. I'm going to talk about it at the end of the video. So for resource gathering basics, we got hard coded to probes per mineral patch, and over here, if you look, there's 3 probes collecting gas from the gas refinery over here, and there are no idle workers as requested in the resource gathering basics. All the workers are working. The idle units are all military units that are waiting for enough units being built for an attack to take place.
Hello everyone, in this video we will be showing you how our bot is successfully able to execute a build order list from a provided text file that is being read from a bin folder. Let's start with our video, and I would start my game first. I need some time to arrange my stuff so that it's very clear how we are working on our build order. So as you can see, we have started building a pylon right now, and assimilator for collecting gas, the gateway, and on the left side, as you can see, I have printed a list of our build orders, so it's more helpful to understand if we are building on right way. So second gateway, now we'll be producing a zealot on gate number 1, followed by pylon, and then we'll be producing 2 more zealots on 2 gates. Yes, as you can see there, we have got 2 gates, and you can see that we have 3 workers collecting gas right now, which is our requirement. And we have produced pylon, forge, cybernetic core, yes, photo cannon. We'll be producing 2 dragons. As you can see on the 2 of the gates, we have started producing a pylon again, followed by 2 zealots on 2 gates, another photo cannon, and next will be gateway. Yes, there you go. So as you can see, we have successfully produced our build order in a sequence as expected, and I think that's working perfectly. Since our build order is completed, now we'll start following our rule-based system. As you can see, we keep on producing photon cannons and pylons as we need, and we also keep our gateways engaged for producing zealots and dragons continuously. As you can see, we are producing more and more. Apart from that, I would like to show our code for how we are performing and reading build order. So it's under starter bot cpp file, where you can see a function called get build order. Here we are reading it from bin build order.txt, and we read every line and store it in as a array and then push back it to a dequeue. And the thing that I show in our video where we had a printed list of, that's where we are printing our build order. So that's it.
In this video, I'm going to demonstrate our scouting abilities. So as you can see over here, we spawn on the bottom left corner of the map, and the bot is wired so that it will start looking from the opposite direction of where we are, so because that's where the enemy is most likely to be. As you can see in the bottom left over here on the minimap, it will traverse like the map in a sequential way, so it will go up, down, up, down, up, down until it finds the enemy. And looks like we found the enemy over here, so we're gonna go over there and try to harass the workers if there are any, and see it's gonna try to attack one of these workers over here. Oh, and it got attacked really fast and it died, but we still have the record of uh, all the last known positions drawn in circles over here and whatever they are. So there are a bunch of probes over here, and there's a gateway being built, a pylon, and we can see basically how many probes they have and what units the enemy have. In the next video, in the next clip, basically I'm gonna try and demonstrate our our harassing abilities. So it attacked the worker again, and it's running back to base. And once it reaches base, it will go back to harass the worker again. You can see last known positions by those red circles. So it will attack again and then run back again. And it will keep doing this until it dies. So over here. So we found a base and our drone attacked them, and now it's retreating because the Zerg drones attacked back, and it's gonna retreat to our base. And when it retreats to our base, it's within range so that our scouts will attack them back. So this is our first successful base defend. Actually, not first. This is the first recorded on clip successful base defending, where we killed a bunch of Zerglings that tried to attack at our base. And yeah, the train came to our base, so it attacked back. Our defense got triggered, and we attacked the enemy basically. This is for defense as well. As you can see, we have built a photos cannon for defense for our build order, and we'll be creating more defense as the build order executes. This is another example of our expansion being calculated correctly. So we calculated this expansion base over here, which is smack dab near the minerals. The calculation, we also show the calculation on the top left. Also, we have met the condition of building a new expansion base, which is having that many enough minerals. So the bot will go over there. We need 400 minerals as we pass that threshold. The bot is getting over there, and it will build our second base over here and start collecting minerals. For now, it's gonna go back to our original base because all the minerals are over there. But this is our, as you can see, Protoss Nexus being built. I'm gonna wait until it's fully built. Oh, never mind, it got attacked. But that still demonstrate our finding resource and natural expansion and building our resource over here. Thanks.
Hello everyone, welcome to another game where we'll be showing about attack timings for our game. In this game, we'll be primarily focusing on showing you how our condition for attack is being calculated, and once it's successful we'll be showing how the game sends our army towards known enemy locations and eventually destroying the enemy locations, their buildings and their army. So as you can see here, we have found our enemy location. As you can see the location on the top left side of our screen, and we have started our build order right now. So the way how we are calculating our attack timing is, if we have found enemy and the enemy hasn't attacked at our base, we'll be waiting for 30 attack units to be built, and once they are built we'll be sending our army to found enemy location and destroy their building. But in case if enemy attacks our base first, then we'll be waiting for 20 units to be built, and once they are ready we will be making an counter attack on them. So let's see how this game goes. So as you can see, we have started producing dragons and zealots as an attacking army. Also, as you can observe, we are placing more and more photon cannons at our base so that we can make our base more defensive and good at it. As you can see, we had some enemy at our base and we have destroyed them, and after that, since we already had 20 units for attacking, we have sent our army to enemy location, and as you can see, we have started destroying enemy buildings and their army. And looks like a good game for us. At the same time, you can see we have kept some of the workers at our base just to keep on continuing producing, gathering more minerals and producing more and more attacking units just in case we lose the game. But as you can see, we have won this game. Let's play one more game and see how our attack timing is being managed. As you can see, we have started our build order, and we have also found our enemy location, as you can see on the top left corner. So if enemy hasn't attacked on our base, we'll be waiting for 30 attacking army units to be built, and once they are built, we'll make an attack if the enemy location is found. And if enemy has made an attack on us, then we'll make sure we have 20 units to send them back to enemy location and make another attack. So let's see how this game works now. As you can see, we have started producing zealots and dragons, and looks like we have almost completed our build order now. So I'm expecting to have enemy at our base, or maybe our army might get ready earlier than enemy. Let's see. So as you can see, after completing build order, we keep on continuing producing more and more pylons, and we place more and more photon cannons to make our base more defensive. Looks like we are almost close to 30 attacking army, and yes, you can see we have got 30 units ready to make an attack. And since we have found our enemy location, we are sending all our attacking units to make an attack on enemy. And in the middle way we are attacked by our enemy, and as you can see we were defeated and they have attacked our base.
In this clip, I'm going to explain how our A star algorithm that calculates the least uh, amount, like the least length path to our enemy base, would be used for choke point detection as well. So the blue area over here is our base, and the red area over here at circle is the enemy base. And let's assume that the A star algorithm would find the base like this. So this is the exit. It finds the choke point, goes over here because it's going to take the least intrusive path, and then it's going to go through here and then come in through their checkpoint as well. Once we find this path over here, we would take each node in this path, and we're gonna do like a area check, basically, like which has the lowest amount of space available. So when it gets near the checkpoint, we would detect there's not a lot of space available over here, and it only has like a narrow amount of space for something to go through. Let's say only 3 by 3 tiles can fit through here, but over here a lot bigger tiles can fit through. We will do this for like the for all points, and they will be a lot bigger over here, and we would have a cap on how big this gets, because we don't want to go through the, like, we don't have to go through the entire map like this. It doesn't make sense. So it would detect 2 of these choke points over here, because this would be another small point like the enemies, and we would build more of our defenses near the choke point over, so that we wouldn't be easily, our base wouldn't be easily attackable. For this, we created a tile node, which has a tile, the cost, the state evaluation value, the parent, and a constructor, and a compare node. This is like this this is meant to be like an iterative deepening A star search. So we are gonna, here cost is the depth, so we sort this priority queue in terms of like depth, and if the depth is same, we look at the state evaluation value, which is a value based on how close the node is to the goal. A iterative deepening A star would be quite a bit faster than A star. That's why we chose this route. And over here, if we came of our detect choke point code, we set up our variables and set up our open list. And we initialize our open list with the root node, which is the player's location. And once we have the player's location, it's just normal A star from this point, where we try to open the node, uh, push the node in closed list so we don't check it again. And if we're near the goal, like the enemy location, we stop our search and we find the path. But if not, we expand the current node to check up, down, left, and right, and give it like a evaluation tile node value, and increase the depth by 1. So we're in each step we're taking care of in which depth we are. The evaluate tile node is determined by the tile location, where the tile is, and the enemy location. This code triggers once the enemy is found. We get the distance between the tile location and enemy location. We subtract it from this number, which is considered a large number over here. And depending how close it is to the enemy base, we're gonna get a higher number, basically. I mean, we're gonna get like keep a higher number because the distance would be smaller. So that's how the A star algorithm with choke detection was supposed to work.